In this video, we will generate the Legendre polynomial using Taylor-Maclaurin series sum, combine, array formula, data validation, and LINEST polynomial regression. Legendre polynomial y equals the summation of a times x to the minus 1 over 2 to the power k, where the value of k is from 0 to n. So here we have our n, data validation, from 0 to 10. So here are our n values from 0 to 10. And the value of k is from 0 to n. So this is equal to sequence of n plus 1, one column starting from 0, incremented by 1. Because our n starts from 0, our k starts from 0 to n. So n equals 1, value of k is 0, 1, n equals 2, value of k is 0, 1, 2, n equals 3, value of k is 0, 1, 2, 3. Now we can generate the Taylor-Maclaurin series sum using our array formula. Series sum. This is x minus 1. So that is x minus 1 over 2 raised to the power k, or raised to the power starting from 0, incremented by 1, and the coefficient will be this range, which is a. Just add one more column. Here you have the trend line equation, or also the Legendre polynomial, and the trend line. We continue with the coefficients, which is array formula. Start with the first term, combine n k. So combine n comma k, n comma k. Now if this is empty, this should be 0. So we have to correct this. So it is if k is empty, and this is 0. Otherwise, calculate. Now it's corrected. So if this is empty, this should be 0. Now we continue with the next term, which is combine n plus k, comma k. So times combine n plus k, n plus k, comma k. Enter. So now we have the Legendre polynomial. We start with 0. At n equals 0, our Legendre polynomial y equals 1. So that is y equals 1. At n equals 1, Legendre polynomial y equals x. So 1x. At n equals 2, our Legendre polynomial y equals 0.5 plus 1.5 x squared. So 0.5 plus 1.5 x squared. At n equals 3, our Legendre polynomial y equals negative 1.5x, which is this one, negative 1.5x plus 2.5x cubed, 2.5x cubed. The rest are 0. And Legendre polynomial n equals 4. So our Legendre polynomial y equals 0.375 minus 3.75 x squared plus 4.375 x to the fourth, which is this. N equals 5. Legendre polynomial y equals 1.875x or 1.88x minus 0.875x cubed minus 0.875x cubed plus 7.878 x to the fifth. This one. N equals 6. The Legendre polynomial y equals 0.313 plus 6.5625, which is this, x squared, minus 19.68 x to the fourth, which is this, plus 14.4375 or 14.4 x to the 6. At n equals 7, Legendre polynomial y equals negative, so minus 2.18 or 2.19x plus 19.68 or 19.7x cubed minus 43.3x to the fifth plus 26.181 x to the seventh. Legendre polynomial at n equals 8. So at n equals 8, our Legendre polynomial y equals 0.273 minus 9.43x squared, which is this, 9.84284x squared, plus 54.14x to the fourth, which is this, minus 93.84x to the sixth, which is this, plus 50.27 times x to the 8, which is this. At n equals 9, Legendre polynomial y equals 2.46x, which is this, minus 3.094 x cubed, which is 36.1 x cubed, 140 x to the fifth, 141 x to the fifth, 201 x to the seventh, 201 x to the seventh, 94.96 x to the ninth, also known as 95.95 x to the ninth. At n equals 10, the Legendre polynomial y equals, it should be in the middle, at n equals 10, our Legendre polynomial y is 0.246, negative 0.246 plus 13.5 x squared minus 117.3 x to the fourth, or minus 117 x to the fourth, 351 x to the 6, 352 x to the 6, minus 427 x to the 8, and 180 x to the 10. If you want to know how this is derived, you can check other videos on LINEST polynomial regression. This completes the use of Taylor-Maclaurin series sum to generate the expansion, and combine array formula and data validation and LINEST polynomial regression to generate the Google Sheets Legendre polynomial.